What does it really mean for an AI to think? Today, we're diving deep into Interview.net design patterns. The architecture of your answer is the product. Modern .NET interviews assess pattern fluency as systems thinking, not rote catalog recall. Static knowledge fails. Pattern composition, trade-off articulation, and runtime reasoning now differentiate candidates. This is a framework for that signal. But here's where it gets interesting: the catalog trap. Memorizing 23 gang of 4 patterns is insufficient. Interviewers discard checklist answers. They test contextual selection, anti-pattern detection, and pattern degradation under load. Most candidates prepare isolated definitions, not interconnected reasoning. So what's the real problem? Let's talk about root cause, pattern isolation. Patterns are taught as disconnected templates. Candidates can recite Singleton, factory, observer, but cannot sequence them within a request pipeline or middleware chain. Missing relational pattern maps, flow-aware decision trees, and .NET runtime coupling. This raises a critical question: breakthrough, compositional reasoning. Pattern fluency emerges when designs are evaluated as layered compositions. The breakthrough: treat the .NET runtime as a constraints engine. Patterns become structural responses to memory pressure, threading models, and DI container lifetimes. Interview-ready signal, justifying a pattern by its downstream runtime effect. Now let's zoom in on system, the .NET pattern operating model, a 3-layer evaluation framework. Layer 1 runtime constraints, GC generations, async state machines, value type semantics. Layer 2 application topology, request pipeline, domain logic isolation, data access boundaries. Layer 3 pattern topology, creational scoping, structural delegation, behavioral wiring. Here's something most people overlook: components. Pattern categories remapped. Not by GOF groups, by runtime concern. Lifecycle patterns, Singleton, controlled cloaked, transient via DI. Flow control, strategy, pipeline, middleware. Reactive wiring, Observer Mediator via channels. Structural isolation, adapter, decorator, proxy for boundary protection. Think about this for a second. Workflow, interview response engine. Here the scenario map to runtime layer. Identify the coupling point. Propose a pattern group, not a single pattern. State the trade-off in memory.location throughput terms. Refactor live by showing pattern substitution. Deliver a minimal compilable skeleton, not a whiteboard diagram. And this is where things get complex: .NET-specific pattern expression. Abstract factory DI container registration extensions. Strategy-injected funt.factories or keyed services. Decorator middleware pipeline and Scruder registration. Observer IO approbald or channel for backpressure. Patterns acquire first-class syntax and runtime behaviors unique to .NET. But here's where it gets interesting: common failure modes. Singleton overuse without thread safety or lazy initialization analysis. Over-engineering with patterns that increase allocations on hot paths. Pattern bias, applying familiar patterns to problems better served by built-in .NET primitives. Ignoring DI container lifetimes when composing patterns. So what's the real problem? Let's talk about impact. Signal density per minute. High pattern fluency signals, compresses decision time, links code structure to runtime cost, demonstrates safe pattern refactoring, avoids cargo cult application. Interviewers stop testing, they start trusting architectural judgment. This raises a critical question: preparation operating system. Daily, re-implement one pattern in modern .NET, minimal API, channels, span. Weekly. Pattern pairing labs combine 2 patterns under a scenario constraint. Monthly. Timed mock interviews recording pattern justification language. Track pattern decision tree, not pattern count. Now, let's zoom in on future. Patterns as runtime primitives, source generators, interceptors, and ahead-of-time compilation will encode patterns as first-class runtime citizens. The interview will shift from which pattern to how does the compiler enforce this pattern's invariance. Prepare now by reasoning at the intersection of C language design and pattern semantics.